maybe we wait like a minute for people to arrive and get started.
Wait a bit. All right, so I think we have 21 people watching now.
Mm-hmm. Should we start? What do you think?
Yeah, we can go for it, I think.
Sure. So, hello everybody. Welcome to like the first talk in the series of talks for the Robust Speech event. This first talk is by Patrick von Platen. He's a machine learning engineer here at Hugging Face, and he's mainly working with audio models. And he's also the co-organizer of the Robust Speech Challenge. He will give an introduction about like the Robust Speech Challenge and tell you like what it's about and how it's organized. His talk will be around like 15-20 minutes, and then we'll have a Q&A session where we can answer your questions. You can pose your questions in the chat anytime, and I'll summarize them at the end, and we'll see that we can answer them all. So without further delay, I'll hand over to Patrick. I think you're muted, Patrick.
Okay, sorry about that. I think my internet just went off. Okay, great. I think I can go ahead then. And yeah, welcome everybody. I'm super excited to start this Robust Speech Challenge with all of you. And in this talk, I quickly want to give an overview of the week, what we're going to do, and then also ask some questions you guys might have. So yeah, so the idea is really that at this challenge we tackle kind of speech recognition systems that will work in robust and settings. That means we don't want to just evaluate the models in the end on read out audio data, but really on real world audio data, and also try to boost the acoustic models with language models. And I think at the last speech challenge or the last speech sprint we've see now. Okay, great. So we'll start with the timeline of the challenge.
I think you cut out for a minute or two. Maybe you can repeat like the very last thing you said.
All right, perfect. Thank you. Yeah, so in the beginning, I just want to share the timeline of the challenge, so everybody knows what we're going to do and when we're going to do it. So today you can see the red circle. Today's Thursday, and the challenge will officially start on Monday, the 24th of January. We have already given access to the OVH cloud GPUs as of today. So starting today until the end of the speech robust challenge, which will be on the 7th of February, you can train your model. By training your model, that means training your acoustic model and your language model. Starting on Monday, when the challenge will officially start, we will be giving you full support on Discord. So as a Hugging Face and also 2 members from the OVH cloud team. Then on Wednesday, probably next week, we'll release the real world audio data for the development set. So you can start evaluating a model on some real world audio starting on Wednesday already. And then at the end of the speech recognition challenge, which will be on Monday, the 7th of February, we will release also a hidden test set. So the idea is really that you're going to get access to some hidden data only at the very end. So we cannot over-tune the model on this set. And then I think in 3-4 days, we can evaluate all your models on this test data. And we'll probably give the results on Thursday then, on the 10th of February. Great, okay. I think now the most important part is to guide you guys a bit through all right, I'm just gonna stop sharing this and, well, now it's stuck, Maru. And I'm gonna share the most important file of the challenge, which is this one. So pretty much all your questions, they should be answered in this README, which you can find in the Transformers GitHub repo and the Transformers examples, research projects, and robust speech event. So here we've kind of condensed all the important information in one README. I would recommend that you start with the too long to read, too long didn't read section here. And then the section should link to all the other important sections here. So normally you should find all the information you need in this document. And to give you a short overview of every section, the event will only be done in PyTorch. It should use transformers and datasets. So one section here which explains how to install those libraries. Then we have one section about the data and how you can preprocess your data. This section is very important because it explains a bit what data you can use and also how you can preprocess the data. Preprocessing is very important because for example, you want to remove punctuation usually for your acoustic model. However, you should not remove letters so that the model can cheat. So this section explains a bit how you can normalize your text without cheating. Great. Then the next section is all about how you can fine-tune the acoustic model. By the acoustic model is the wave-to-vec modelment. And this section explains everything step by step, how you can fine-tune it. The section afterwards explains how you can do this with the OVH Cloud GPU. Was a nice spelling error here, actually. And there's also a very nice video that Bastien from OVH Cloud team just put online. And you can also see here how you can set up an account and how you do the training. So this should also be very important. Then the next section explains how you can add a language model to your acoustic model. Adding a language model is very useful to avoid spelling errors and also just in general to boost the performance of your model. Actually, 1 second, I'm just going to turn the light on. Otherwise, it's a bit too dark here. All right. Okay, cool. I think that's better. Great. Then we will go over the next section, which is the evaluation. So the evaluation, there are going to be 3 datasets normally that we will use for the evaluation. The first one is the test set of Common Voice. The second one, if possible, will be some real-world data that we're going to release, as I shown before in the timeline on Wednesday next week. And the last one will be the hidden test data that we're going to release after the sprint. And that's pretty much it. One very important section is also the communication problems. So you're probably going to encounter a lot of problems, and that's very nice. So we want to help you to tackle all of them. So everything which is related to bugs, to errors, please ask the question directly on GitHub. So either on datasets on the GitHub repo or directly on transformers. And ideally, what you can do then is you create an issue and then you copy paste the link into the Discord channel and maybe ping Anton or me or someone else, and then we'll take a look. But the idea is really not to kind of dump the error messages directly on Discord, because this way all the knowledge that we can build by answering these issues gets lost in the long run. So we try to collect everything on transformers directly. Okay, great. That's it. And now in the last step, what I also want to show is a bit how you can use the hub. So we really recommend that you guys make use of the Hugging Face hub for the challenge. And to begin with, I want to share a bit an example. So when you read the GitHub introduction that I've just shown, I'll mention this model here quite often because it was a bit like the demonstration model that I've done for the sprint. And usually when you follow the script, the trainer automatically pushes the checkpoint and also the training results directly as a model on the hub. So everything which is written here was not written by me, but that was written automatically by the trainer. So that's very convenient for you. And all you have to do is actually when you use the training is you add one flag which is called push to hub. And push to hub allows you to directly upload all the checkpoints and pretty much all the files in your GitHub repo to the hub. And that's very nice because then you can see right away what error rate you have here. It's easy for other people to see. You also can actually record already, so you can use your model already here for the inference API and record and try it out here. So I could now compute here actually the answer or the transcription to the audio. And it's also very convenient if you're used to TensorBot to see all your metrics right away here. So I strongly recommend everybody to use this push to hub option. Great. Okay. Then in the last step, I'm going to jump back to some common questions that for sure will pop up during the event. And okay, great. I think like one common question most people have and some people already ask on Discord is what data can be used. The idea here is really to use all kinds of data you can find. So I think as a start, what you can do is you can start by looking at the Hugging Face Hub. So I'm going to share this as well real quick. So what's very nice is we collected already quite a lot of data sets for audio. So what you can do is when you're logged in here, you go on Datasets, and then you can just kind of filter here by, should be something with speech processing, and then you can see we already have 32 datasets here. So feel free to combine any of them if they suit your language. For example, well, Common Voice, I guess the Common Voice 7 here is probably the most important dataset for you. But then also there's the multilingual Libre speech, which has also a lot of data for certain languages. So feel free to combine any of those datasets if they suit your target language. Great. Okay, then I also think some people already asked what models can be used for fine-tuning. You can use any model you want, which is you can also, if you want, you can also train your model from scratch. But I strongly recommend to not do this because it's usually much easier and gives you much better performances to fine-tune a pre-trained model. Probably the most relevant model here is the new XLS R model from Facebook. And we have it in three flavors. So we have the 300 million parameter version, the 1 billion parameter version, and the 2 billion parameter version. In my personal experience, the 300 million parameter version works pretty well for almost all languages. So so all of these checkpoints have been trained on pre-trained on 128 languages, and they should work pretty much on every language you want to fine-tune it on. And the 300 million checkpoint is quite easy to fine-tune. The 1 billion actually as well. So I think you should definitely try it out. And the 1 billion checkpoint also fits on the GPU given by OVH. The 2 billion checkpoint might be a bit difficult to fine-tune because it's not super stable anymore at this size of training, and it might also take quite a lot of time. And you have to use tricks like kind of optimized like low memory optimizers, and I'm not even 100% sure whether this fits on the V100S, but feel free to try it out. So in general, you can use any model, and we also evaluate every model the same. So we don't really care whether you use a small model or a big model. We kind of look at the final evaluation, and this doesn't mean that you should always use the biggest model. The purpose of the whole event is that you kind of create, or that we help you create a model that is most useful for your task, and not necessarily that you have to win the competition. I think the competition is a very nice side motivation, but if for your personal project or for your use case, a smaller model which is obviously faster and inference makes more sense, then please use that. And we'll make sure that it works well. Great. Then questions. I think I already answered this. So everything which is bug related, please ask directly on transformers or datasets on GitHub. The questions now, which are a bit related to your special use case. So those are questions where you think the other participants might not necessarily profit from the answer that much, and it's probably not a bug in one of the libraries. Then maybe go ahead and ask on the forum. So I added the link here, and then we're going to answer on the forum directly. So the idea is really everything which is related to either how do you fine tune Wave2Vec, or this doesn't work, we're going to make this work, or this is a bug, should be as public as possible, so that everybody profits from it, and also after the event. All other questions I think can be asked directly on Discord. So everything which is related to the event itself, like your name didn't pop up in the Google Sheet, or anything regarding the organization, or whatsoever, please ask on Discord. And you can also, if you have problems, if something specifically doesn't work and you don't want to open an issue and you're too lazy, it's also all right to use it, to do it on Discord, but then I'm probably gonna remind you to please open issue on the transformers. But in general, we're really happy about every issue and every bug we get, and we want to help you as much as we can. Great. Okay. Now, one of the biggest questions is also whether your language, the language that you want to work in, has real-world audio data for dev and test. And so Anton did an amazing job at collecting some very cool kind of real-world audio. However, we don't have real-world audio in every language, and we're probably not going to be able to find this. So for example, languages like Esperanto, which is not even a real language, it's very hard, to find real audio data. So there we just might do the final evaluation directly on the Common Voice test dataset, and only on the Common Voice test dataset. However, there are a lot of other languages where we didn't find real audio data yet. And after this talk, I'm going to share an Excel sheet in the Discord. And in case you have any good resources where you can find or can extract data from, we would love to get them, and then we can use them for the dev and the test set. And the idea is here that we obviously want to be very sensible to what data we can use, and the data is going to be private, and it's going to be used only for evaluation, and it's going to be it's going to be private, so it's not going to be public for everybody. So you can also we're also going to verify whether we're allowed to use the data, so you don't have to be scared about any licensing. We'll take care of that. But I kind of want to shoot out here to languages like Tamil. We didn't find any real data for Tamil yet. Luganda is another huge language in Common Voice where we sadly couldn't find any real world data. So in case you have any good links to data, to resources, we'd love to have them. And right after the talk, I'm going to share a Google Sheet where you can add them. Usually the best way to find audio plus transcription is YouTube. Quite often you find good data there. Otherwise, you just kind of have to search in the language actually itself and try to find some websites where there's some reasonable data that can be used. Great. So that's from my side, and now I hope there's some questions, and I'm ready to hear them.
Yeah, so there are two related questions that we can maybe answer in one go, by Francois, who's asking what happens if you upload a model multiple times, and Emilio asks how do models get versioned on the hub? Can I push multiple models with the same name? I think those two questions are related. Maybe you can answer it in one.
Yeah, that's a very good question. So I'm also going to share my screen here again to show this directly. In short, yeah, we have Git version control for the models, which is very nice actually. So if you uploaded a new model again, what happens here? For example, I think I've uploaded multiple models here. So you can see this is the repo, and now when you go on tab files and versions, you can see that there's a history here, and that's very similar to your Git history, in a normal Git repo. And you can see here great commit messages by my part. But you can see here that I've uploaded multiple models, and this is kind of like a Git history. So for example, what happens here already is during the training, you upload checkpoints. You can click on it and you can see that I've uploaded all these files. The model itself, in this case, is the PyTorch bin. And this was uploaded, I think here it's step 500. This was done automatically, actually, in the trainer. And then, oops, sorry. No, I jumped out of the history. And then you can see it's overwritten by every training afterwards. So here you can see step 1000. And here we overwrite the model. It's not actually the real model that is going to be put in the hub. So what happens here is that the model weights, they're hashed. The hash are compared. When the hash changes, when you re-upload the model, then it's overwritten. And then when you download this file, it links to the new weights, which are identified by this hash. So in short, it's all based on Git LFS, and it works very similar to Git. And you don't lose any model if you upload a new one. You can always go back. You can actually specify the version when you download the model. Yeah. Sorry, I think was there a second related question?
No, I think that answered both. So if you use the trainer and push a model twice with the same name, it just creates a new commit. I think.
Yeah, exactly. Yeah. And you can also afterwards you can overwrite it again with your own commit, kind of like I did in the history also in the end. So those were my commits, and you can also add like a new model. So for example, in the second training, there's going to be then a new kind of like string of update steps for the trainer. And I also strongly recommend actually that you, for example, if you work on, let's say, multiple languages, I think you should, for every language, you should have one model repo. So let's say I worked on Swedish here. If I find out that there's some much better training data and I'm going to retrain my model, I should do it in the same repository. If I, however, want to work on a new language, let's say like Swahili, I'll open a new repo and push there. So yes, really every repo corresponds to one language. If you have an improved model, just upload it right away in the same repo.
There's another question. You showed like TensorFlow integration on the hub, and GigaBlaze asked like, is there also an integration with weights and biases?
Yeah, that's a very good question. I am actually a huge fan of weights and biases. I think we didn't manage, or we didn't do it yet. I think there might be even on the roadmap. However, the trainer is connected to weights and biases. So if you just pip install weights and biases locally, and you start the training script with the Hugging Face transformers trainer, then all the metrics that I've just showed in TensorBoard, they're also uploaded to your weights and biases account. So that's actually very smooth, and I personally also use weights and biases a lot because it's great. But we don't show it here. We don't display it here on the repo yet. Maybe it's going to come. I'm not sure actually.
There is another question from Clever asking, why would you use another language? The test set is in English, right?
Oh, sorry, no. So maybe I wasn't very clear there. The whole competition is going to be for every language. So if you have the best model in one language, you kind of won that language in a sense. And we have test sets for every language. So at least the Common Voice 7 data set, I think, has 74 languages, and there you find a test set for all of these languages. So when I previously said, for example, you shouldn't use the test data for training, I meant the test data of the language you choose to train your model in. We don't have, sadly, yet real-world audio data for every language. I think we have like 44 or something like this at the moment, and we're trying to get more. Maybe also to add it right now is in case you work with a language where that is not on Common Voice 7, and that also wouldn't have any real-world audio for, then maybe you can just ping us on Discord, and then we should see kind of together how much percentage of your data we should use as test data. So if you have a very huge data set for a language that sadly isn't on Common Voice, maybe you can use just 10%, 5-10% as your final test data and never use it for any hyperparameter tuning or training. If it's a much smaller data set, then we might use maybe like something like 30%. But those should be edge cases. So I really hope that for most languages, we have at least Common Voice data.
Little P is asking, what about training on multiple languages? For example, training on the same family of languages at the same time?
Yeah, that's also it's a very good question. So first of all, pre-training has been done on I guess like simultaneously on 128 languages. So for pre-training, it makes a lot of sense. And also from people that come from NLP, there's one thing which is amazing actually in speech. If you think about it, is the input to the model when you pre-train is always audio. So the format never changes, in comparison NLP, when you switch, for example, from language like, let's say like English to something like Chinese, the whole vocabulary has to change, which also means that your whole like word embedding layer probably has to change, which makes it much harder to pre-train on multiple languages, which often results in these huge kind of word embedding matrices that a lot of models use, or models have to work directly on bytes in NLP. The nice thing in speech is for pre-training, for example, that you always work with audio, so it doesn't matter which language. So pre-training works like incredibly well on like together on every language. And simultaneously. Now, the problem in fine-tuning is in this event, we're mostly going to fine-tune these models which are called CTC models. And there, the problem is that you have an output layer which corresponds to your vocabulary, and more precisely corresponds to the characters in your vocabulary. So let's say in English, you have the alphabet, so you have 26 characters, which means that your output layer has kind of like 26, like a logit vector has like 26 entries. And the problem now is if you fine-tune on multiple languages, there might be a problem. Let's say maybe I think Catalan and Spanish should work actually pretty well. And actually, I think it's a fun experiment to try it out, because I think they share more or less the same vocabulary there. However, if you do things, like again, maybe like Chinese and English, it's going to be very difficult to fine-tune simultaneously, because in your output layer, English needs just the alphabet. Chinese, you need much more like science you want to transcribe to. So maybe in short, for languages that are very, very close, like Catalan and Spanish, I think it's actually a very fun experiment to try it out. And I'm not sure whether it's going to be better or not. I guess for Catalan and Spanish, you do have enough, like data to fine-tune the model just in a single language. For other languages, however, which might be much smaller, like low resource languages, so smaller, I mean, in terms of data, maybe it's a very good idea actually to fine-tune on both languages simultaneously if the vocabulary is not too different.
Cool. Lil P is also asking, like, from last year, they're in contact with like other people, and Lil P is asking like if it's okay to collaborate together on the project.
Oh, yeah, it's a great question as well. Actually, I wanted to talk about this. Yeah, thanks for asking. So yeah, for sure. So we really like want you guys to work together and to help each other. For example, if you have like a group of friends and you all want to work in the same language, please share everything. And you can also, if you want, kind of just like upload one model, and then this can be the winning model, and then you're the winning team. The thing is just like it's very time consuming to organize groups. So for this sprint, we kind of said like we're going to give out one GPU voucher per person. However, if you work together, if you know each other, we're just going to give one GPU voucher to one person of the group, and then you can share, like access if you want. So yeah, please work together if you want to. In general, also, like we should always try to like share our findings. So let's say like you work in a language, you find maybe that there's some great data set out there that like no one has ever seen. It would be very nice if you share that.
We reached like the full time, but maybe we can go over time like a few minutes and answer like the last 2-3 questions that there are. What do you think?
Sure. Yeah, I think we can also go a bit over time if there's some good questions.
Cool.
I think it shouldn't be a
So
problem.
Emilio is asking like which model is going to be evaluated? Is it like the last committed one on the model repo, or another one? How is like the evaluated model selected?
Yeah, it's also a great question. So in short, what we're going to do is there's also written in more details on the README I showed in the beginning, but I'll share this right now actually as well. So I'm going to put my screen up here again. 1 second. So let's say you made a model, and let's say you have multiple Swedish models, for example, under your account. in this case, you can just kind of like add all of them to the evaluation. And the way you add them to the official evaluation is just by giving them a tag, which is called, you can see it here maybe, is called robust speech event. So the important thing is that your model, when you upload it to the hub, has two tags. One is the language, which is SV in my case. And this should also be automatically done, actually, the language by the trainer. So normally you don't have to do this. The other one is this tag. And this you have to add manually. And this is actually very easy to do. So the tag can be added right here on the README. So you can see here, there's some YAML code. And there's one section which is called tags. And for example, if you want to add a new tag, you can just add it right here. So I can, for a talk, you can just add this here now. So I would also actually recommend you to do this right away on the website. And then you can see here, if I go back to the model card, you can see here now I've added this tag, and you can click on it, model for tag. The reason is now that the reason to generate these tags is if you click on this tag, you see all models which have that tag. And here you can actually already see one model which was added to the official evaluation list of models. And then all models that are here are going to be evaluated. So here I should also be able to see the language. TH, perfect. I see the language, and I also have the robust speech event tag. So we can automatically evaluate this model. So in short, what I would do is, again, like as I said before, if you work on one language only, I think it makes more sense you just use one repo. You can also use multiple repos. It really depends on you. If it's easier for you to use multiple repos, you like Swedish version 1, Swedish version 2, feel free to do it. Just make sure that you add this tag that I've just shown. So robust speech event and your language. So we can automatically kind of extract all models.
There is one question about if you create your own private data set, what happens if there's like an overlap between like the hidden test set?
Yeah, it's also a very good question. Wow, very, very good questions. So yeah, that might happen. And then I guess it's a bit like maybe our fault as a collectors of the hidden test data. Yeah, then that's maybe lucky for you. Like your model should perform very well then on the test data. So yeah, that might happen. Honestly, like there are not that many like platforms to extract data from for audio. So this might happen, and then it's fine. Then I guess you're lucky. However, as I said before, the competition, is a nice side kind of motivation for the event. The real kind of like reason of the event is that we try to kind of work together to build useful models for everybody. That's also why I said you can all use like the biggest models, and people that have maybe like 8 GPUs available, 8 A100s, they can train much bigger models, and they're probably going to have better performance, and that's fine. But in the end of the day, really hope that like the model that you fine-tuned and the knowledge that you gain during the event is very useful for you. But then at the same time, yes, it's very nice to kind of like win this challenge, and like we try to make it as equal and as fair as possible, which is incredibly hard, obviously. And in this case, we can't do much. If you use the data that might be in the test set for your training, then lucky for you, I guess, and that's all we can do. Maybe regarding datasets, also one thing I quickly want to show you as well. So even if you have private data, for example, for the event, and you're not sure whether you want to like use that, you can also upload data in private mode. So I can show this here maybe real quick. So I made this. Or maybe like I'll just show it here right away. So for example, if you want to add a data set which has some sensitive data and you don't want to share with everybody, you can create also a private data set here. So sensitive data in Swedish, and you can create it here, and then you're the only one who can see that. But you can use it, as just like every other data set. So you can add a README here, or you can also actually directly kind of upload files, So here, actually, for example, I could now upload some dummy data, which might be sensitive, and then you have all the data directly here. Then you create like some model card, and you can use it, super easily. So here I can just this is 2 lines in Python. It downloads your data. In this case, it's just text data. We can also upload the audio data or whatever. It downloads your data set automatically. And you have all the advantages of the dataset library. The important thing is, because it's a private data set, you should pass this flag, which is called use authentication token equals to true. but then you can use it, and you can also be assured that no one has access to your dataset as soon as you make it private. If after the sprint you want to share it with everybody, you can also flip it here to a public dataset, and then everybody can see it and people can like it. Yeah, so maybe there's also as a small extension. So I strongly recommend use datasets. I think it's incredibly handy and useful library for datasets in general. And if you have some private personal data, you can use it in private mode. And that's fine. You can also just use it for the sprint and delete it afterwards. But usually, if you put it up in private mode, it's like if you put it up in private mode, it's secure. No one can see it, and it's just your data. Yeah, that was maybe a bit more than the question, but I think that could be useful.
Yeah, I think it also answered some other question. Maybe to round out the question answering, there are like 2 questions related to post-processing. One person is asking, is like something like automated post-processing allowed? And another person asks, how are Ken LM going to be integrated after the fine-tuning? Is that covered by the scripts provided by Hugging Face?
Sorry, could you repeat this? I think my internet went down again. Sorry.
Sure. So the first question was, can you add like your own automated post-processing to your model? And the second question was, how is Ken LM going to be integrated after the fine-tuning? Is that covered by the scripts that Hugging Face provides?
Cool. Yeah. Yeah, for sure. So maybe the post-processing first. So like any processing that you want, which kind of like stays within the rules, which is also gray zone, I guess, the rules. But in general, you can add any post-processing that you want. For example, let's say you build an automatic spelling corrector, in like maybe like a nice NLP model that you put after your speech recognition system that corrects like some inconsistencies in sentences, and in the end it gives you a better word error rate. Super good work, and that counts. However, if you build some kind of post-processing which cheats in a way, like which maybe makes use of the test data, then that's not allowed to even look at it. It's also related to this is maybe a bit like you should remove all kinds of punctuation, I think, because normally punctuation doesn't have an acoustic sound. So like we think it's totally fine to remove punctuation and to normalize your target data and your output data from the model. However, it is not allowed, for example, now to, let's say, like in English, you want to replace like all vocals with one vocal letter. You say like all vocals are going to be the same and they're all going to be an A. Then it doesn't work anymore, because then your words lose their meaning. Then things like, like words like hello would suddenly be like something like hala, like just like one like vocal for both vocals. And that would be cheating, and that doesn't work. And then like the model can like lose its purpose. So yeah, like in general, post-processing, feel free to kind of do whatever you want, as long as like you don't cheat in that sense, that you make it too easy for the model. More information is also written on the README, by the way. And the same counts for pre-processing, by the way. So if you want to do noise filtering, great, you go ahead, and that's perfect. Just we have to be careful to not make it somehow too easy for the model. And also maybe like again, like one thing is if you know a language very well, if you're a native speaker, and you, for example, you find out that in Common Voice has some like letters that that like don't exist anymore in modern languages, and actually like one-to-one the same as other letters, then you like feel free to like replace them with the correct letters and make it easier for the model, because there's some like messy data. That's great. But like you kind of have to make sure that the output of the speech recognition system doesn't lose its meaning, so that it's still like it's functioning. But yeah, I really recommend also like for this case to ask maybe like a native speaker, and ideally you are actually a native speaker in the language you work in. Cool. The second question is actually also a very good question. Is the KenLM, and I wrote actually a blog post for that I'm gonna show now as well. So there's a blog post that's also written in the README, by the way. But if you go on blog on the Hugging Face Hub, you can find here there's a boost wave to vector with ngram, and by ngram it is KenLM in transformers, and it's a very in detail blog post which should explain exactly, first of all, how do you collect, or like how do you get the data to create your KNLM, and then secondly, how do you create it actually? So I think like all the commands actually here. So here you can see this is the command that like KNLM build n-gram model. So this shows exactly how you can do it. And I actually recommend you can do this directly in the Colab. So there's a button here as well. And then you can run all the commands in the Colab. And you can actually, like, I will recommend to just do this in the Colab because you don't need a GPU to create a KNLM. And you can actually just change, I think it could be as easy as just kind of like changing the language that you want to work in. So here I work with Swedish. So if you want to work for another language, I think you could actually just change that and maybe some other things further below, and it works out of the box for your language. Cool, yeah. And then the last section also explains if you've created the KNLM, how you can integrate this with transformers. But there's also a very nice talk right after this one from the Kensho guys, which created the PyCTC decode library, which explains in detail how to work with the PyCTC decode library and how to integrate the KNLM model.
So that's
great.
A great transition to the next talk in 20 minutes.
Yeah. Maybe actually I wonder, like, I think there was one question here. I think someone said, yeah, we should all use the same test data. I forgot. Oh yeah, I think Clever Clover said this. So I completely agree. We should all use the same holdout test set for sure, 100%. And that should also be the case. Like, no one should train their model on the common voice test data. And we might actually like verify this. So if you see that the model gets incredible error rate on the test data, but the training doesn't look very good, then we can check, like we can run some like short kind of scripts to check whether the model has been trained on the common voice test data or not. And this should not happen. So you should not use the common voice test data because this is held out test data. There should be no hyperparameter tuning, anything on this data. It should be looked as like a hidden test set. So I 100% agree. Like, there should be like the test data should not be used for training. And the same thing with the real audio data we're going to release. They should not be used for training. That's only for evaluation. Yeah, and like I think the question before was just like, in case training data overlaps, we can't do much, sadly. But yeah, cool. Okay, I think this is it pretty much from the questions, no, Leandro? Or
I think so. And I mean, if we missed any question, then you can always ask it also on Discord, and then we can answer it there.
Exactly.
Or if we didn't answer your question.
Exactly. All right. Yeah. Thank you so much. I think the other talks they're probably a bit more interesting. This was just a short description of how the event looks like, and I think the other talks they're going to be super in depth and interesting actually. So I really recommend you attending those. And then if you have any questions, just feel free to ask also in the Discord. Like general sprint channel. And otherwise, yeah, I'm super excited to see some powerful speech recognition systems in a lot of languages. Great.
Cool. Thanks a lot. And in that case, I close the broadcast.
Awesome. All right. Bye-bye.
Bye, everybody.